A very good evening to all of you. Welcome back to my channel. This is Shivam Shukla and here I am to solve a problem on engineering mechanics. It's a problem on resultant of parallel force system type 2 to find the resultant force and replace it by two parallel forces at two different points in the system. Let's see how the question statement goes as. So now replace the force system shown in figure by two parallel forces at points B and D. Now if you can see my dear friends, this question was asked in December 2018 in question number 1A for 5 marks. So what are we supposed to find? Let us see and proceed for the problem. Now we will be writing here first of all to find, and then we'll be going step by step. So to find is nothing but R and its perpendicular distance D. That is the first part. Second is we are going to replace it by two parallel forces at the points B and D. That is we are going to find FB and FD. Okay. Now let us proceed for the problem step by step. So step 1, we will be drawing the FBD. So draw FBD. Okay. So with the help of this, now I'll be drawing a free body diagram over here like this. Okay. Now different points will be plotted one by one. So this is over here A, this is over here B, this is the point C over here, and here is D. Okay. So now one by one I'll be plotting the forces. So this is 15 kilonewton, this is 40 kilonewton, 4040, this is 30 kilonewton, 3030 kilonewton, and this is 20 kilonewton. Let us show the distances one by one. Here it was 0.5 meters, here it was 1 meters, and here it was 1 meters as well. Okay. Now let's go ahead step by step. Step number 2, solution. Solution. We are starting with step 2. Is now what are we going to do? As you can see, it's a parallel force system. All the forces are in vertical direction. So therefore, it will be R is equal to summation of all the forces in y direction, considering in upward sense as positive. So therefore, if I consider now R is equal to summation of all the forces, so plus 15 minus 40 plus 30 minus 20. The same with the help of the calculator, my dear friends, we'll be doing it over here. I can see the diagram a bit uppish. I'll be taking it over here. So it will be 15 minus 40 plus 30 minus 20. So it's done. So it is minus 15, my dear friends. So now I can take it over here. Therefore, R is equal to minus 15. That is equal to 15 kilonewton. That is nothing but equal to 15 kilonewton in downward sense. 15 kilonewton in downward sense. Okay. Now next step will be step number 3, that is location of R. Step 3. Step 3, location of resultant. Now let us assume that the resultant, let R be located at a perpendicular distance d, small d, to the right of A. Small d to the right of A. Therefore, now if I see the figure again, so it will be simpler for me to just apply the Varigman's theorem. So what does Varigman's theorem states, my dear friends? It is nothing but, therefore by Varigman's theorem, summation of moment of forces about a point is equal to moment of resultant about the same point in the system acting in clockwise sense as positive, my dear friends. I am considering. So if I see the questions diagram, 15 won't be considered as 15 is acting at A. 40, 30 and 20 will be considered. So how it will be written over here? So let me check. It will be plus 40 into 0.5 minus 30 into 1.5 plus 20 into 2.5 is equal to R into D. So it will be 15 into D. So let's go ahead with this, my dear friends. So therefore, if I write the equation, so it will be, again I'll be seeing over here, you can check the diagram. So it will be 40 into 0.5. So therefore 4040 into 0.5 minus 30 into 1.5 plus 20 into 2.5 is equal to R into D. So R is nothing but plus 15. Why? Because it is causing the body to rotate in clockwise sense. So therefore, my dear friends, D will be equal to. Now let us see the calculation. So it will be 4040 into 0.5, that is into 0.5, minus 30 into 1.5 plus 20 into 2.5. So here it is. Value is 25 divided by R is nothing but 15. So value is 1.6. So therefore value of D comes out to positive. That means our assumption is correct. So therefore D is equal to 1.6 meter to the right of A. Now we will be going for the step number 4. That is part 2 of the problem. Second part I will be writing. Step 4. If I say this as the second part, so what was the first part? First part was nothing but this one. I'll be writing it over here. This is the part number 1, step 2. So step 4. Now, my dear friends, let FB and FD be the forces, the two parallel forces which are acting at capital B and D respectively. Okay, so now we'll be drawing one diagram again just to give a proper clarity, my dear friends. So let me draw it over here. Okay, let me simply extend it over here. Yes. So now if I see one by one, let me name the points. So here is A, here is B, here is C, and the other one is D. And what have we assumed is these forces, that is FB is acting in vertically downward sense and FD is acting in vertically downward sense. That we have simply assumed it. Okay. Well, now what is given to us is already this is 0.5 meters, this is 1 meter, and this is 1 meter. One more thing, what we have already found out, my dear friends, is nothing but the resultant. If you see, with respect to A, resultant is passing somewhere over here. I'll be just showing the resultant. So this is resultant R is equal to 15 kilonewton. And one more catch is, with respect to point A, the distance of resultant which is already there with us is nothing but 1.6 meter that we have found out. Now let us find out what are the values of FB and FD. Okay. So now, as you can see this particular diagram, forget the rest of the things. Now let us just stick to it. Now we can say that summation Fy is equal to R, acting in upward sense as positive. Therefore, from this diagram it will be minus FB minus FD is equal to minus of 15, because that is R. To be specific, we can write it down, my dear friends, FB plus FD, taking minus sign as common and then just removing it by cancelling it on both the sides. We get this equation. Okay. Now let us proceed for equation number 2 by using Varignon's theorem. So it will be comparatively easier, my dear friends. Just check it. Check the diagram and I'll be writing it over here. By Varignon's theorem, applying for the second figure, that is figure 2. The above one I'll be writing and taking it as figure number 1. Figure 1. Okay. So now by Varignon's theorem, it will be algebraic sum of moment of forces about B is equal to moment of resultant about B. Now you will be confused, why did I apply the moment about B, why not D? It was vice versa. If you would have applied it about D, you would have got the value of FB first. Now I am applying about B, from left to right I am going, that's why I will be getting the value of FD first now. Okay, so let me just check it, my dear friends. With respect to B, FD is causing the body to rotate in clockwise sense, so definitely that will be taken as positive. So therefore FD into, with respect to B, D is at a distance of 2 meter, is equal to moment of resultant about B. With respect to B, resultant is at a distance of 1.1 meter. 1 meter plus 0.1 meter over here, as you can see, because it is totally at a distance of 1.6. So this distance gonna lie is 0.1 meter. Okay, so 1.1 into, sorry, the value of resultant R should be written as first. So I'll be just erasing out this. Just always keep in mind, my dear friends, whenever we are taking the value, we should be taking the force first and then the distance, because the formula itself says force into perpendicular distance. So it will be 15 R into D, and D is nothing but 1.1. So now if you can see, I'll be taking the value over here, and it will be 15 into 1.1 is equal to divided by 2. So the answer is 8.25 kilonewton, and that is of course positive. So I'll be taking it over here. Therefore FD is equal to 8.25 kilonewton, and of course it will be acting in downward sense. Why, friends? Because the value we got it as positive and we got it as per our assumption. Therefore now I'll just using 2 in 1. So it will be FB plus, many people get confused now, plus FD it is, and the value of 8.25 we should take it as plus or minus. Friends, we have already taken the value of FB and FD both as negative, and accordingly we have we have framed the equation, because we got the value over here by framing the equation by considering FD in downward sense. That is why definitely, my dear friends, it has to be taken over here as positive, because already the negative sign was taken. So it will be plus 8.25 is equal to 15. So ultimately FB is equal to 15 minus 8.25, and so it will be 15 minus of answer, and that will be last but not the least 6.75 kilonewton. So it is over here. FB is equal to, therefore FB is equal to 6.75 kilonewton. Again the value is positive, means our assumption of the direction is correct. So this is over here. Now friends, how the marks are going to get distributed, just for the knowledge sake, let me tell you all one thing, how the marks are going to get distributed. The entire two FBDs that we have drawn will be getting 1 mark. Total 5 marks are there. 1 mark for this R, again 1 mark for the value of D. The FBDs individually, both of them will be comprising of one half marks. So half mark for this FBD, and again at the top if I see over here, half mark for this FBD. Now remaining 2 marks will be there directly for the final values of FB and FD respectively. So 1 mark for this and 1 mark for this. So friends, this is how the problem gets completed. Please do like, subscribe and share this video. Thank you for watching this video.